Yeah, like all kind of crazy, and it was like, you know, the girl like pop like this all songs and everything, but what happened was that somehow took one of them first.
So we are actually recording right now. So welcome everybody to the second RPIrates monthly meeting of the fall 2024 term. And I'll take that. Who's been to RPIrates before? Yeah. And who hasn't been to RPIrates before? And we're a little bit leaning on that side. As I explained a couple of minutes ago before we started, RPIrates is meant to be this informal gathering of our community on the RPI campus. I like to say we're the only ones that are pirates, and they can do that because of RPI. RPIrates has been around for almost as long as Professor Kristen Bennett has been leading the Intro to Data Math, data analytics research sort of sequence of courses and related projects. And we have hundreds and hundreds on our RPIrates email list. So what we're going to talk about today is an R-based web application called ChatBS, which we created more than a year ago, probably about 18 months ago, in response to what we were seeing from ChatGPT. About 18 months ago, ChatGPT had just been released. It was seeing popular usage, and the model that was being used, the GPT model, was 3.5, which was very prone to what some people call hallucinations. It would do a great job answering questions, and it would, and a lot of the answers were really crappy. Okay, so a couple of us down in the Taylor's World constellation down in Winslow building wondered, could we build an application that sort of did a fact checking? Could we build some sort of a framework for fact checking? And so let me get over to where the actual, sorry, I have to find my window. Okay, so do I need to zoom in a little bit, or can you see this okay? I can zoom in a little bit more. So this is the current, this is current ChatBS. And it's looked a lot like this since its creation. I'll describe what you see right now, and then I'll kind of describe its evolution. And as you know, the standard way to interface with a large language model is to provide some sort of system, what's called a system prompt, some sort of contextual prompt. And that's usually something like, "You are a helpful assistant." And I should say also, this sort of way of interfacing and prompting an LLM, it originated really with the GPT models from OpenAI, but it has evolved over the last year as kind of a standard that other providers of models have adopted. So it's almost like we'll call it a de facto standard. There's no organization that has declared a standard, but other models such as Llama 3 from Meta and others have sort of adopted this way. You provide a helpful assistant, and you can play with that. You can say, "You are a malicious assistant who's very unhelpful." Okay, and that will affect what the response. And we can play with that. The user prompt is usually what you focus when you hear about prompt engineering. It's usually the user prompt that you're modifying. By the way, how many people have worked with LLMs? Or hacked with LLMs, done internships with LLMs? Usually have, but yes. So, okay. So you can kind of see on the surface at the first approximation, what we have here is a pretty standard. You've got a you've got a system prompt that you can customize. You've got a user prompt that you can customize. If I scroll just a little bit, you've got some other interesting things. You've got a model selector. So here's a client that I could choose one of these models. And as we'll see after we play with this for a bit, I can actually choose all of these models and submit the same set of prompts to each of these and compare the responses from each of these. You can see here, there's we're presenting result. It tells us what model that this result is for. And it's got this text here. You see that text is highlighted. One of the sort of features that we have is it takes the sentences and it turns these sentences into Google queries. And that's a form of fact checking. But it turns out to be a very effective form of fact checking. You take a sentence, you throw it at Google, and you can you either get a result or not. This is, by the way, this is has been one of our standard test questions. What's the oldest technical university in the United States? Do we know the answer to that? I think we know the answer to that, right? Well, these LLM models don't always know the answer to that. Particularly Llama, particularly the GPT-4o, we'll see that they don't always know the answer to that. But Llama today, right now, in this submission, knows the answer. ChatBS has part of its reason for living is experimentation and to make experimentation really easy. So we have this ability to select how many times these prompts are going to be submitted to the model we select between 1 and 10. And the idea for that is these are not deterministic. That you will get 10 different answers if you submit your prompt to that LLM. And if you're experimenting with this, one is not good enough. You experiment with anything. One run is not a sufficient run. So we've got this capability to submit, and it's not a chat kind of thing. It's not being fed back in to somehow make it better. These are 10, up to 10 unique submissions, and you see them listed here. If you do that, we've written papers that have used ChatBS to provide additional data that goes into appendices, and it's very convenient to be able to create a machine readable log of your experiments. So we've got a downloadable JSON file that specifies using the JSON structure, what the timestamp is, what the model that was selected is. If I want to compare the models of each model that's selected, what the prompts were, what the result was, and we can read that JSON into the code that, or just slap it into the paper that we're writing. Another thing that was very important when we created this, so Corey was asking the name, ChatBS. Where's that coming from? It was originally created with the idea that we might be creating a fact checker, that this might be the start of some sophisticated thing. And so one of the thoughts was, could we, for certain kinds of questions, could we parse those results, and could we parse those results into relationships, subject, predicate, object, and create a graph that represents that in what's called RDF, Resource Description Framework, create a graph of that result, and then somehow use that graph as a basis for determining if it was a correct answer. Fact checking is extremely difficult, as Mark was pointing out. It's very hard for people, like even CBS, to do fact checking during the debate.
Yeah, rapid fire.
So, but what you can, I will show what, let me, I'm gonna change the model here. I'm gonna go, just because I'm gonna, so I'm gonna ask GPT-4, which is a year-old model, but it's still one of the best in terms of, so we see we have a nice simple answer from GPT-4, okay? Now I'm going to, because it's kind of expensive, we don't usually have the RDF generation turned on. There's a whole separate backend code written in Python that actually uses GPT-4 to construct this graph, to parse and detect the relationships, parse this result into what essentially is this relationship graph. So RPI has location Troy. RPI is an instance of an institute technology. Okay, and these are the fact that these are not grayed out means that these are actually tied to. Those are actually entities in Wikidata. Okay, so this is a graph that in theory we could actually check against some authoritative graph. These are relationships that could be related to a formal ontology. So this is kind of the reason, but there's only certain kinds of questions that we can ask. You know, one of our tested questions had to do with who is Barack Obama's wife? You know, questions like that. You get to like simple question, simple answer, nice graph, that sort of thing. But you can also see though that we're querying based on what the subject is, the subject entity, we get this result. So this is actually why this is being presented very soon at the International Semantic Web Conference, is this tie between LLM generation of answers and then this relationship detection, entity resolution. That's a cool thing, but that's not very entertaining. What's one of the kinds of experimentation that you do with LLMs is, and there's a is whether to what extent do the LLMs, are they able to do reasoning? Okay, and there's a kind of an emulation of reasoning called chain of thought, and LLMs do this usually particularly well. So built into ChatBS is this ability to add to the prompt to say, explain step by step. And I'm demoing this on GPT-4. As I'm doing this, I'm burning credits on my credit card. But so it takes quite a bit longer, and you'll see how it will expand its result. And it'll come back, see what it did there. And it's listing, and those of you who have played around with this a lot, you'll see that it's, this is kind of the standard stuff. It's got an expanded result. It kind of pads it through, and it looks like it's doing this chain of thought reasoning. There's a new model, which was just made public a couple of weeks ago, which is from OpenAI, that supposedly does reinforcement learning. This is in beta. These two, O1 preview and O1 mini, do supposedly do this reasoning, and it's not quite chain of thought, but it's a more expansive thing. This is, we can compare, if we ask for, let's ask for, see how different the so and so I'm showing ChatBS right now, but you should also be thinking, I'm showing you a web app that is built in R using the R Shiny framework. And I'm also showing you an app that has been made publicly available. It's a multi-user application in the sense that we can have multiple people hammering away. We use Docker to containerize this app and publish it. And the most amazing part of the whole thing is we got it through the .cao's policies so that we can actually make an app publicly available. That's probably the biggest achievement of all. And we can actually thank COVID for that, because we had Kristen Bennett and I had a very, very large team of students working with us during COVID on a whole set of analyses to help open up the campus. And we created several apps that were intended to be public for helping other colleges open campus, helping students on the RPI campus find what the predicted occupancy. That was a student design app called StudySafe. And to make those public, .cio had to ease up on some policies, and that gave us a framework for moving forward and publishing apps. So from before COVID, it was, but since COVID, we've published many. So you see the difference here. Same model, multiple submissions, different responses. They all are more or less correct. And you have this ability to down. One of the interesting things that OpenAI says, at least with these beta models that do reinforcement learning, is don't ask it to do the chain of thought. Don't give it the chain of thought trigger, explain step by step, because it actually confuses it in some way. So there's still, that's a fascinating thing. Yeah, Corey.
I have a fact checking question.
Yeah.
In the third result, at the very end, it says it's been a leader in these STEM fields for nearly 2 centuries. I'm pretty sure it's been exactly 2 centuries, and everyone should be aware of that.
So
I can't miss that.
yes, okay, but isn't that a fundamental problem with LLMs? Is when was the model built? Okay, they're not updating. They're not updating their model all the time. So yes, it's been 200 years. Yes, we're celebrating it, but so far, OpenAI doesn't know about the Ferris wheel and the carnival.
OpenAI hasn't seen the drone show?
They haven't seen the drone show even, although my 40th reunion classmates did. Yeah, that's right. I graduated 40 years ago. All right, so one of the things I wanted to show was kind of compare this is a really, really new feature of the ChatBS, is the ability to compare the results. See the variation. This is the O1 preview. This is that GPT-4 Actually, the better model I find is 4 Turbo Preview. But part of the point of ChatBS is what I'm doing right now. Okay, is I'm able to just mix and match, try these different models. There we go. So, and then let's see what else is on here. So we have the ability, if you actually ask for that graph, you have the ability to do that. So I'm wondering if there are any questions about like the functionality, just the basic functionality of ChatBS. Yes.
Do you have any token limitations on the responses that these give?
So there are limitations on what so this is my API key. In fact, the reason why we're able to see some of these models is because we've been hammering it nonstop for 18 months. Okay, so I get to use like the beta on the O1 pretty early on because we've been using it and paying for it and that sort of thing. But to your point, there is like a token, well, there's two things. I think there is a fundamental limit that I have for my level of how, but I also have the ability to set that limit. Now, what's interesting is one of the reasons we think that both the 4.0 models and the other models seem to be not as good for text is because they are multimodal models. So 4.0, for example, can do image related stuff as well. And so they're allocating tokens for that mode as well as the normal text mode, but it's kind of like a fixed amount of tokens. Whereas the other GPT-4 models are just text tokens. Same thing with the 0.1 models, but they're doing it a different way. They're allocating those tokens for the reinforcement learning. So they sort of like, if you think of memory space and you've got a certain fixed amount of memory, the GPT-4 0613 and GPT-4 Turbo Preview have like the whole space. It's for text. These other models are they're chopping that up, so you don't have as much available. But there is some limit, and I've never hit the problem. You know, in case of it's never come back and said, "Don't gonna work."
I'm just wondering, like, for your own sake, I usually, like, in my experience, I'd have to limit tokens so that it wasn't like running off and spending, a couple bucks worth of tokens in one go.
RPI is paying for mine. So, which it ought to do, right? This is, anyways, that's a very good question. There are other questions are like, do we diddle with the things like temperature and stuff like that? And we're just using, I think you may have asked that question before. We're just using defaults on it right now. Okay, you want to see a little bit of code? You want to see how it actually does this? You don't have to see the trigger warning. You can see R. Actually, what I could do, so that's not the app you want to see. Let's see here. To show off. Actually, I not know if. I don't know if this is. This is scarily old. That would be dangerous for me to show you. I literally could show you the code as it was in March. Let me do fresh. You don't want to see Mars? So the structure of a Shiny app. So what is Shiny? Shiny accomplishes a couple things in R. There's a UI section that allows the user to describe a basic UI. So if you're familiar at all with HTML, essentially what you're doing in R is kind of a functional description. You're using functions to create this user interface. You're also specifying different user interface widgets, and you're also where you've got input elements, you're specifying reactive variables for those inputs that get used elsewhere in your code. So there's a UI section, and then there is what's called the server section, which implements your various reactive data manipulations. Okay. It also is where you implement your reactive outputs. By reactive, I mean when there is a change to a variable, which is typically an input, but it could be a change, it could be a change to a data frame that was changed for some other reason. So reactive variables or reactive functions can process changes to either input things or other sorts of changes. And for that reason, if you've ever programmed in event-driven models, keeping your events can be tricky sometimes. But it's pretty straightforward. So there's a server section where you define a whole set of functions that both redefine your data based on those changes, as well as things like outputs, different kinds of outputs. Here in ChatBS, it's just kind of textual outputs and some other things like downloading files, but you can think of the various kinds of outputs you can have. You can update visualizations. You can update all the different kinds of visualizations. In ChatBS, we update. There's different text boxes and subject headings and things like that we update. So, and usually in an R Shiny program is a R program. The code is an app.r file. So you are using the same syntax that you would use for any R script. It's not Markdown. You're not doing an RMD file, but you see, and then you follows the usual. Do I need to? I can't actually zoom in here, but
Control plus. Yeah.
this is not a Mac. I could do like Control plus.
Oh, and then scroll your mouse.
Control plus.
Or go to the settings and just increase the font size.
Or I could do it over here. I could do settings. I should. Unfortunately, I'm viewing this code in. I'm using my desktop version of our studio, not the server version. Don't tell Dr. Erickson. So let's look at a couple things here. So you've got your library. You've got your library calls. Typically with these apps, we don't embed install packages in them, because when you run that app, what it's going to try to do every time is it's going to try to install those packages. So there's that user interface aspect of you want the app to come up quickly. So you're going to use a library and a library instruction. Just make sure that your code is, that your packages are installed. Any sort of global variables, things that aren't going to change, maybe there are data frames that you're going to use throughout your code. You just do that as you normally would at the start. You see that there's some startup prompt text, startup prompts, any debug code that you might have, debug things. There's some base URLs that we have. Functions that are not reactive that you might use through your code. If you could here, I'm defining these functions in my main app.r. I might have helper functions that I define in like a utilities.r file that I might source. So a separate file that I would read in at the beginning. So it's that what I'm trying to emphasize here is the usual structure of the just normal code, normal function definition. But then I get into my UI section, and this is typically how it works. There are the basic styling is in a Shiny app is done by you can bring in like a certain set of styling with these different top level functions. Fluid page is a particular kind of HTML markup that where the elements on the page are managed in a particular way, margins are allocated, that sort of thing. You can also have fill page. You can also have nothing. You could also, you could potentially just go in and have really basic markup. But you can see here, I've got many instructions that are, and I apologize that it's probably hard to see. Oh, you know what? Okay. A little bit easier to see. And then this screen, unfortunately, tends to be a little bit pale, so you might want to look at that other one. But you can see the kind of the elements of structure here. We've got functions, and these are provided by the Shiny the Shiny package. When you import the Shiny package, so one of the things we do, there's a little bit of JavaScript that I do to support one of the buttons. It could be the button that does the download. I'm not sure which button it is. Oh, I know what it is. It's you can type in a question and hit enter, and it actually pushing a button. So I've got a little bit of JavaScript that does that. And so just like HTML, I've got a script tag which imports that in. Okay, so a very simple example of how this is kind of equivalent to how you might do HTML markup. You see, we've got line break tags. We've got an image tag. See, you see, it's a kind of a functional metaphor for coding it in. Now, what's really interesting, so we've got a particular layout. If you remember the interface, there was a kind of a set of inputs on the right side, and then there was a main part of it where the result was presented. That's done in this way. There's a sidebar layout where we've got those widgets for doing inputs. And then we've got our main panel. This is very typical. If you go online and you look for Shiny examples, typically there's something like that. And, it might be some random draw a histogram with MT cars data or the iris data. And it'll have like a sidebar panel, and it'll have the main panel, and you'll manipulate it. You'll choose the species on one side and you'll do that. That's what we're doing here. And you can see here, I'm creating a reactive variable. There will be the input prompt. There's a submit button. So somewhere I got to process my submit button. I have to choose how many retries I want to do it. So I chose to do it in this fashion, just a kind of a drop down and select, with one being the default. And then there's a place for so still on that left side, that if we're creating a graph, if we're doing that RDF output, put the Wikidata page for that entity which was identified. Okay, then we got our main panel. Main panel is typically where you put, a lot of your descriptive text. You put here we're going to put our result in there. So you can see so at the top, we just got some basic HTML that doesn't do anything. It's just text. But we get into where we do our results. Now we got some interesting things going on here. If we're doing multiple retries, we have to cycle through. So here's a way that you can wrap an HTML output. We're actually going through result text output 1, 2, 3, 4, depending on how many we selected. And then we've got another one of those. Then we've got a download button for downloading the RDF graph. There was a download button. There should be a download button for This is a data table for the RDF. There's our results. Oh, so I think I implement the download for the JSON of the result in that thing there. Okay, so, but this is pretty typical. This little bit is not very typical. This is a trick for having cycling through it. Notice it's done in a functional way. It's not a for next. Okay, so that's the UI. That's the markup for the web page. And then this is a really interesting part. This is the reactive stuff. This is where we get into actually, how do we query the LLM? How are we actually doing that? So first we initialize some reactive variables. Sometimes we give them initial values. So each one of these, inside the server, these are all values, data frames or single values, vectors that we expect to be updating as we interact with the program. So where we plan on changing it due to our interaction, we're going to define those here. And sometimes it's very simple and sometimes it's very complex. And then, depending upon how your program works, you may want to have an initial value as a default. Sometimes you can just have it be a null value and it'll work. It really depends on how your program is going to work and how you want to interact with how you want your user to interact with it. So here's the heart of the whole thing, the submit button. So you kind of get the gist of how Shiny works, how the reactive side of Shiny works just by looking at this. I've got this function saying observe event. Well, what's the event? I want to watch for the submit button being clicked. So changes to the submit button. We refer to that by saying from this input object, which is maintaining this, is watching over it's a structure which is watching over all of our inputs. There's a child object called submit, which we created when we created that widget. Just watch for a change to that object. And then do what's inside of that. Do what's inside of the curly brackets. And there's a lot that's going on here. I won't do that in detail, but I'll just point out some things. One of the things that we do is we need to have we need to get the prompt from the UI, but we don't want the submit to trigger every time we change that, every time there's a change to that prompt. And so imagine you're interacting with it and you're typing in, and each time you change it, it does a resubmission. Okay, so the way R handles that is, or the way Shiny handles that is, there's an isolate function. And what that's saying is, take whatever the value is, but ignore any changes to it. Don't trigger, because what Shiny will actually do, even though this is my observe event, what R does is it does what's called invalidating of a reactive value when there's a change, and it wants to change everything. It wants to trigger this observe event, even if that's changed. And so this is the complexity of event-driven programs. So you just manage that by wrapping it, by isolating it. So we only want observe event, everything inside here, which is mostly submit our prompts to the chosen model to happen when we do that. If we go on down here and we see I'm not really sure why that is in here. That might be a test thing or it gets changed. It's really weird. I'm looking at the right version of my code.
It was commented somewhere earlier that we would be using that model.
Yeah, I know, but not all of my comments are, but it's not doing that though. So and I'm opening this locally, so I might be opening up an old version, in between versions, but that's not the point. The point is, let's look at what's going on here. Oh, okay, let's see. So what's happening here is it's creating this, so this is, where is the outside of my loop? So in this version of the code, it's actually, God, this is not quite right. So I'll show what's here. Just to kind of show at least how it used to be. I think Corey was right. This is a bit older. There was, when we looked through the UI, I couldn't find the download JSON, right? I couldn't find the download JSON. So this is an older model. So this is how it used to be, but we'll show it. So there's a function from the OpenAI, from a version of the OpenAI R package, which provides the interface capability with the OpenAI API. And our default here was to use this, the original 3.5. This is my version of my code, but the function was create completion. And you can see very simply, this is like, oh, I know why. Corey, you didn't, you let me get into the wrong directory.
Sorry, Jim.
Man,
I won't let it happen again.
I'd never let it happen again. Okay, let's go back here. It's much better. Here we go. So, starting again, here's our submit button. We have to pull out, what's our system prompt? What is our, remember the system prompt is the one that says, I am a helpful assistant. Okay, and so we're doing the isolate of that. What's the actual user prompt, which we're just calling prompt? Whether or not we've got that explain step-by-step button ticked, whether or not we've got provide references. Provide references is something we threw in for one paper, which is essentially for your answer, give me citations. And we see, depending upon the model, we see it actually try to give references to the answer that it gave. Sometimes it does quite a good job. Sometimes it may give an author's name. It'll give a plausible paper title, which may not be by that author, and may then give a link, which may not be the link to that paper. It may not be an actual link at all, but it will actually try. It'll help hallucinate, if you will. All right, so we see how we actually do that. We construct, we take whatever the base prompt was, to isolate on that. If they ticked explain step by step, we do a paste zero, which is our string manip. So we tack explain step by step on the ad. If they ticked include references, we tack that on it. So we're doing like really primitive prompt engineering here, adding it on. And those of you thinking of, what did we call it? The CTBS app for, you can think about how you could have like additional text boxes that you could have different things, or you could have like maybe some preset text that you could add on to experiment in different ways. Okay. Each one of those checkboxes that I had, they were just checkboxes, but they had strings that you would add on, but you could just as well have text that you could add. Okay. So, so we kind of cache that away. We go into the actual code where we're going to submit it. And this gets kind of complex in its nesting. But here is, so it's actually kind of good I showed the other one, because when I first did this with the 3.5 model, it was create completion. Boom. That was it. It was very simple. Well, how does it look when we have to submit multiple times? How does it look if we have multiple models? How is it going to look like that? Well, this is what it looks like now. So I created a function called insistent create completion, which the long and the short of it is I take, I'm doing the create completion submission, but my code keeps going like this until I get a result. And this is because the OpenAI API is rate limited. And you may find this if you're just writing code that hits APIs, they may be set up this way. What that means is you can't reliably hit that API. Like, here's my prompt, give me a result. Here's my prompt, give me a result. If you do that, if you actually watch what's happening when this is executing, you'll submit it, you'll get a result. Then you submit it again and say, no, submit it, no, yes, no, yes. It literally does that. And so I've got this, this is set up in a particular way using an R function that lets you do that and lets you do the intervals. And it's so it's a very fault tolerant way. And it's not that it gets around the rate limiting, it just deals with the fact that there are a gazillion users getting it. And we're just one of them. And this started to emerge last year. All of a sudden, ChatBS was failing, and it was failing because there was such a deluge of users. So we, maybe we're contributing to the problem. I don't know. And then there's a lot of code in here that does list management, creating the kind of the care and feeding of the data structure. So the result that comes back, the result that comes back from the API is a JSON result, and we have to kind of pull these pieces out and kind of vector into it. And meanwhile, you might have noticed that progress bar. This is how that's implemented. It's increment progress, and you can do progress bars pretty easily on anything you want if there's multiple steps that are happening in your code. If you actually are incrementing like through a loop, as I am here, there's a basis for doing that incrementing. It doesn't really work to do like a time-based, like say you've got, it just takes a long time to do, but it's just because it takes a long time, it's not incrementing. That's harder to do. So that's that little, but it's fun to do that if you can, if it's like this, it takes a while. All right. So the rest of this is just, it's just putting it all together. This is a little bit of code this is the actual code which create the render UI, which is the opposite of what I've got in my interface, which is a UI output, which is a basic text output. Render UI is actually putting that result text, whether it's one result or many text results, putting that into this thing called result text output, some number, result text output 1, if it's the first one. And if you remember, in the UI section, I had a loop, right? That was the length of my thing. So this is creating each one of those result text, 1, 2, 3, 4, 5, 6. And then that up above in the UI, it was processing that. Right? It was dumping that out. And then we're getting to the end here. So that's that's the really interesting part. What I wanted to go back to for the LLM people in the crowd, people are here for. I wanted to find the implementation of, so that function that I use to do insistently, that itself is not a reactive function. So outside of my, it should be, but actually it doesn't matter where it is. It can be, I happen to have defined it. Okay. So I created a function which I labeled risky create completion. Okay. Originally, it was called create completion. Create completion was the very simple submission of a simple submission to either GPT, to OpenAI, or to, if it's the case that we've selected Llama, we have an internal Llama 3 instance set up internally. So that's our for free. That's why Llama 3 is now our default, because we don't pay for that. You pay for that by your tuition. So we just added this code in the last like 3 weeks. So if the model has GPT in its name, this is really very simple stuff. Then we use the client is OpenAI, and it knows to send this to OpenAI. But the client software very recently allows for you to specify a different endpoint that you're pointing at. In our case, we're pointing at the Llama instance inside of RPI. So if you selected Llama, if you didn't select GPT, we're going to point there. Same prompts. This is the beauty of what Llama has done, is they've adopted the same structure for prompting. And so when you're interacting or sending, launching code, launching prompts at this, and so this is, if you're going to be hacking LLMs, you know, this is the stuff to pay attention to. And now, granted, this is using this wrapper that we have, so but the same should be true. This is where you're actually sending off. And I believe that, you know, the Python interface is going to be very, very similar to this, but this is where you're actually sending off. These are the parameters of the completion creation. Is what's my model? This has changed. This has evolved like 3 times since they published last year. You know, this structure. This is what we've had to edit as these new models have come out. We've had to, like, oh God, you know, what are they doing now? Okay, but there's a system. The system prompt, the user prompt, the system prompt actually for the O1 models, the reasoning models get ignored, but it's a very, yeah, go ahead.
You have to update some logic here. The O1 models don't start with GPT. So right now, the O1 models are probably just calling Llama.
Oh, that's interesting. Maybe that's why they're crap. That's good. That's a, thank you. Thank you. Thank you very much. That's a good catch. This is why we do code review. Thank you, Aaron. Everybody meet Aaron Green. He's the one who's going to be fixing this code. I expect your pull request. Okay. Thank you for that. That's awesome. Actually, Enrique should have spotted that.
Yeah.
Because I told him what I was doing. So.
Yeah, pass the blame.
Yeah, that's right. See that? Shift a root. Okay. No fact check. I thought there was not going to be any fact checking in this presentation. And then the rest of it. So this insistently is the function from, I'm not sure actually what the R package is that does that, but insistently is the function that based on some rate that I set up above, I believe, that keeps resubmitting what I call risky. The reason I named it risky is if I just hammered away with that call, it would fail. That it was failing before. So I called that risky. I wrap it in insistently, so it automatically with that rate does that. And I call that, and because this is functional, I don't worry about all the parameters. And I'll set these parameters and it'll pass through wherever I call this insistent create completion, which I actually call within my reactive thing down below. And then I just wanted to, I don't think there's really much else to, I mean, there's a lot of details here. And if anybody who wants to see the actual code, I can share the GitHub with you. I wanted to touch on a little bit about how this is deployed. So on the idea cluster, if you've got an account on the idea cluster, there's like an automatic way to publish Shiny apps. You know, if you've got a home directory on the idea cluster, you can literally just have a directory with your app.r in a subdirectory called Shiny apps, and it'll automatically make that available, that app available on the internal RPI network. Okay, it's a little bit risky because it's one process, and if you've got multiple people hitting that, multiple users are actually driving the app, which is kind of a scary situation. But it's great for if you're doing some research and you want to share, you know, with your advisor. Here's my code. Look at that. They can play with it on the network. In order to share it safely externally, so that you've got one user, one process, so you can scale the app, we use something called Shiny Proxy. And what Shiny Proxy does is, if we use a container platform like Docker, a containerization platform, we create these Docker images of our app, and then each user that goes to the URL for ChatBS gets their own process. So if you've got 100 users, they've got 100 unique processes. They're not interfering with each other. It scales. And so when we publish these apps externally, we go through kind of a flow of we do a Docker build, which is basically just a way to kind of create this nice packaged environment. We deploy that on a virtual server, and Shiny Proxy says, she gets one, and he gets one, and she gets one, and he gets one, and it works really well. This app is a little bit more complicated because we've got that backend which does the RDF generation, which I didn't show you the code for. So there's a separate Docker thing for that. But Docker has been a real godsend for us, allowing us to very reliably deploy these apps in public and safely. So RPI actually lets us do that. And there aren't many departments around RPI that are actually able to publish apps for people and do things at scale. We, like I said before, we did it for, so Mortality Minder, which is our oldest public Shiny app, was in a different way. It was kind of scary deploying that. But everything since COVID, we've deployed using this Docker model, and we can do it very quickly and very powerfully. So that's ChatBS. Are there any questions? Yeah, there haven't been a lot of questions that I've been going along, but so the people that are going to be building, you think you got what you need to start? and you got any questions you have about our Shiny stuff from ours?
Oh, actually, yeah. With the isolate one though, like the isolate function, that's
Yeah.
like if I press the button and observe event, then we automatically go if I press that button, right?
That's the purpose. Yeah. So if I So there's two sides to your question. If I've got an isolated reactive variable in a reactive function, like an observe, it should ignore changes to that.
Yeah.
That's number one. Number two, if you want to react to that, you have to have an observe event, which is watching for that button to be pressed.
Oh, okay.
Right, yeah. So it's a way of doing it specifically. I want changes of state to trigger. And you saw that I had those two check boxes. I isolated those and I didn't so you don't get it if you
Because it's all.
click, do explain step by step, it won't do anything. But it knows that you click that, yeah.
So are you saying that like, if you put in a prompt and have explain on and then click submit and then click explain off, that it
It doesn't change.
doesn't change
It doesn't change.
It's already like saved mentally, not mentally, but
Well, that's a way to do it. It doesn't, so the better way to say it is it doesn't look at that. It doesn't process what the state of that is until you hit submit. Okay, so it's not that it remembers, it's not gonna, it ignores it unless as it's dropping, it only goes through that submit or goes through that logic if you hit the submit button. It's hard to get,
submit.
well, yeah, before you hit submit,
You can toggle back and forth.
it doesn't, yeah.
And it just, yeah.
And you saw the counter example of that, what the opposite, if you saw me when I was hitting that RDF button, whenever I hit the RDF button, you saw things happen. And I hit the RDF button and went away. I hit it, went back. It wasn't a button, it was a checkbox. I don't know why exactly I did that. It works very well for demoing, and that may be why I left it that way, but that's dangerous. Okay, and that's what the behavior would be like if you didn't isolate that input dollar explain.
Then you don't want things changing every time you keystroke.
Right. And it's actually kind of an existential debate that I used to have with one of our grad students was, I really, really like reactive interfaces. I changed something, I wanted to do it, but it doesn't always work. It doesn't always give acceptable results, and it can be a performance thing. If it changed, like one of the things that's not reactive is number of submissions. Okay, imagine you just like randomly went from 1, it was set at 1 and you said 10. Okay, and imagine it instantly started reacting to that. I didn't want to do 10. It's going to take forever for that to happen. So
There's no way to interrupt that.
no, there's no way to interrupt it. So the solution is
But- Yes, Control C.
right. We don't have Control C implement. Any other, these are good questions. Any other questions?
So the 3.5 model, is that the, like?
3.5 is defunct.
Okay,
Yeah, when we were looking at that, I was looking at old code.
okay.
That's why I switched. It was beneficial because it allowed me to contrast with the new code. But that was a mistake. I was looking at,
Oh, okay.
I went too far. I went into a repo that it was actually March of last year. It was like right after I wrote it. It's like one of the first versions of the code. So it's actually kind of fun to look at that, but scary. Showed me how much code I've done since then. All right. Any other questions? And you're going to get right to work on that, fixing the code.
Yeah.
So.
I'll delegate it to some of my.
There, yeah. So thank you, everybody. Take food if there's food up there, please. Thank you for coming. And if you got any ideas for what you'd like to see in a future RPIrates, please let me know.
I can't play with it, but
I literally got it.
today,
Yeah.
I didn't know we had an emergency RPIrates meeting a couple weeks
I do.
ago.
I actually,
Like a pirate day.
stupidly enough.
And I'm just showing that.
This is a model of it. It's actually my third remarkable, but it's like the newest one. And all the ones are pretty awesome.
See.
One day added. like an e-ink screen, so
You
it,
can change like
We actually have,
yeah, so it actually has a colored screen now instead of.
did have one here,
It's really nice.
Pirates.
No distractions, like if it were an iPad or something, but you could have like apps that like,
Yeah, yeah.
and you can
First thing.
like set.
All right, I'll go.
Email.
Thanks, Dr. Erickson.
Yeah, I lost my like.
Yeah, it is.
But you never,
Do you need, did I miss anything important?
Oh, I see.
Really. I mean, yeah,
Out, it looked like, but not how it was.
to be fairly.
oh, okay,
Like,
actually,
if we were, tomorrow, we're gonna note,
important thing to realize.
you, I think, you know, take a week or two on future construction, if you're still on that, but then we'll see.
Okay, is that like, would that be an option for tomorrow, or should we start getting into that, like, LLM?
Probably.
So, first demo,
Why don't I just do that, so I don't have to, like,
can call.
Fine.
someone else should try.
I just remember you had said that you were emotionally invested in feature creation, so. Don't want.
Let it go, maybe.
That's a new.
Think about it.
That's right, and it uses a different, just scrolling down to where it starts. And it's, so all this stuff is just standard.
It's like setting what you.
Yes, everything, right.
The basis.
But it's one thing down. So this is, you see, multi-window shiny.
Very early days.
What it does is it creates, there's a structure that is it's a list of windows.
30
And this is multi-window shiny syntax here. These are the names of the windows. Controller, floor, whatever, and then.
Control like the.
Well, controller is, it's actually kind of a dummy window. We don't even use that, but floor is the map.
Yeah.
Which any weapons?
Basic.
Monitor two is actually the one on the left, you know, the big, you know, I mean, that's monitor two, and you see, when you look at here, see, this looks like normal, normal shiny stuff. Dashboard page. Well, no, it's like what I was showing,
Oh, yes.
what I was showing, but it is, it's normal in the sense that this is a normal tabbed
Yeah.
interface. So you can see here, there's these different tabs. This is how you lay it out. So this is, this in itself would be a.
So
That'll happen.
multiple things, they can interact with each other.
Well, that's what they had.
No, it's, all the interaction is happening, it's one app, okay? It's
Windows is one window, but the windows can interact between them.
they're not well, so the interaction is, so technically it's not, I'm sorry to be kind of picky.
No,
It's,
no,
it's, it's a single app and it just has different windows. And so all the interactions that you're having, you know, that when you're interacting with the window, you're affecting the same mass of code. Okay, so that's like you might cause a change in a data frame. Okay, so the canonical example in the Mars app is what sample sites have I selected to look at? Okay, and so so what you do on several different windows, you know, whether it's the map or it's like from a table or whatever, the thing you're always doing in the Mars app is like selecting things, okay? So that there's a data frame, which is, or a vector, it's probably just a vector that's keeping track. It's a reactive thing that's keeping track of what you've selected. And that's being used by a whole set of functions to manipulate what outputs you see at different places. So I select something here, I see changes on those two windows, okay? That's not the windows interacting. That is your users interacting
Yeah.
with the thing which is causing the
I
change.
phrased my question wrong, what I meant was like, they're not isolated, and it sounds like they're
Yes,
definitely
yeah,
not.
they are not, yeah, they are not separate apps. They are,
Yeah.
it's just Windows on a one app, you know, and the magic is kind of how, it's all like, you see here, this is the panorama, which is deceptively simple. The panorama is the wall.
But the thing you're wanting for the app group is to try to make it so that it's not so many different windows. 'Cause
It's just one.
you don't have as many screens. It's just one.
It's, yes, and what.
But you can see any of the info that you want.
And you could, right, well, you could, we have to decide on what we're actually.
Yeah, what's important, what's not important.
But you can see what would, like, one of the things we talked about was like, just now, panorama. But,
Yeah.
but you see here,
I mean,
this is monitor one, so we looked at monitor two,
uh-huh.
up above, this is monitor one, don't ask why, you don't remember. But see, this is also a dashboard page. So one of the things that would be stupidly simple is you just like,
Combine monitor one and monitor two,
well, you.
so that you can do the same stuff.
Yeah, it's all under one dashboard page.
Yeah.
Like, all of a sudden you've got however many tabs that is, like, 10 tabs or something. But you can also see, you could conceivably have, let's go down here.
Let me quickly check it.
So the other thing that's kind of complicated, so there's all these interface, where's the? I was just trying to find, the floor, okay. The floor, I'm having kind of this WebEx argument with CJ right now.
Mhm.
About, stop telling me how it's implemented. I implemented it, okay? But it's, it uses a super powerful package called, so there's some fancy JavaScripty kind of stuff that manages clicking and stuff that CJ's sister did a lot of work on. But this is actually this is the outputs, leaflet output, Jezero map. So somewhere we define Jezero map, which is a leaflet object. There's a whole section, this serve calc stuff are all the purely reactive data things. And if you go down here, somewhere we update Jezero map. This is where we click on a PCA. This is where we kind of thing. Oh, there it is, right there, Jezero map. Okay. So there's an output section of as well. This is all standard stuff. This is if we update the boundaries of it, but this is where if you're updating a leaflet map reactively, you got a function called leaflet proxy. But this is where this is actually what I meant to show you is actually not so much this, but the other thing. You could have a tab which has got the map in it. You could actually have part of a tab which has got the map in it. It's just a matter of there's a lot of functionality that's in this app that you kind of have to put in the correct spot. And that's.
And the tabs are one window, but you, but like separate pages on that window, or?
That's a way to look at it.